Well, hello there. I'm going to do a little bit of streaming tonight, at least tonight for me, wherever you are, it might be today. Probably only an hour, hour and a half. This is a follow-up for the stream I did a few hours ago, and it's because I was reviewing the RFC for URI right here on the left, and found some things that were inconsistent with what I thought before, so therefore they're inconsistent with our requirements and our tests and our component. And I have in our notebook a few of the things that I plan to try to fix. Hex digits, I found out, can be lowercase a through f, which I originally thought, and I guess I had been focused too much on the definition for this hex digit, where it just lists a through f capital. But then there's this clause I found here that they're equivalent to lowercase, so we have to handle lowercase. And then on the similar theme, I found out that several of the elements of a URI are considered case insensitive. And so when we're decoding a URI string into its elements, it's probably a good idea to normalize to lowercase. And that's most notably the scheme and the registered name. And there's an example of that. If you look, hold on. There's like a really good example I found in here for that. Here it is. For example, URI with all caps for HTTP, and then mixed case, for example, is equivalent to all lowercase. And it talks about that the scheme and the host are case insensitive and should be normalized to lowercase. So we're going to do that. And I also found that if you have like dot and dot dot in segments of a path, you need to actually remove them, and there's a procedure for doing that. Remove dot segments, and we're going to implement this procedure. It's not too bad. I also found this bunch of pseudocode in the RFC, and our code is doing a lot of this, most of it in fact. The only thing that we really aren't doing correctly is we're not removing the dot segments from paths. So along the same grain as this pseudocode, we'll be making a function to do the removing of dot segments, and then we'll be calling it from these different places. Also in here that I probably won't get today is this concept of merging paths. If you have a base URI and you are resolving, so to speak, a relative path, which is relative to the base, there are some logic in the pseudocode for merging the path, for replacing the query, and other things. So I thought we're probably going to want a method of URI that takes a base and applies the URI to the base in order to resolve it. A relative URI to be, I guess, what they call a target URI or a resolved URI. We'll do that some other time. But I took note of that, and under to do, I have listed that, as well as some of the other to-dos that I had, checking for IPv6 addresses. I looked up IPv6 addresses, and I have a pretty good understanding now of how those are formatted. I realized that the RFC is a bit over-descriptive here. This looks like a lot of redundant mess. It's just to be verbose, to cover all the ways you can collapse zeros with a double colon. It's not too bad in concept, it's just that they're really verbose in describing it here. And something for later, not tonight, but later, we'll be refactoring the state machines we made and then generating strings from URIs. And I put a little note here that for hex digits, we want to use lowercase for IPv6 addresses, but uppercase for percent encoded characters. So back to the plan for tonight. Actually, I see that I have in here to fix path decoding to remove dot segments, but I have it also on to do. It's probably going to be a lot of work, so let's for now remove the plan. I have a tendency to overplan and try to do too much, so we'll try to just tackle these first three things regarding case sensitivity, and then with any leftover time, we'll do some refactoring. So let's get started on the first thing. Hex digit should allow lowercase characters. So we're going to go to, I don't even have it open yet, open Visual Studio. And in our unit tests, let's see if there's a unit test that covers hex digits already. Trying to remember if there was. I guess the one that stands out in my mind is this percent encoded. There's no unit test that covers just percent encoding, so maybe we'll make one. Actually, instead of writing it from scratch, let me try to copy one of these other tests that has the test vectors in it. So we're going to make a new test parse from string, and let me think about what can have a, let's see, what can have a percent encoded string. Well, I guess it doesn't really matter. I'll just make it simple. We'll just make a simple path. Parse from string, and we're going to call it paths with percent encoded characters. And we'll fix up path here and get path. So what should already work is if we have something like 41, we know that's going to be A. And I should get we should get our ASCII table out. Let's see, what is something with a hex A through F in it? Okay, 4A would be J. So we know that should be J. But what probably won't work now is lowercase a. Should also be J. And while we're at it, let's make sure that something like, well, that's going to be beyond ASCII. Oh, I know a trick we can do. We can just put any arbitrary code here, and we can use escape XBC. Oh, that reminds me, one thing we aren't handling that we probably should. I'll put it in the to-do. Percent encoded characters need, actually it's sequence text elements. Text elements need to be valid UTF-8 encoding, especially percent encoded characters, because UTF-8 being a superset of ASCII, what reminded me is looking at the ASCII table, see how it ends in sub and F. So bytes 80 through FF, you won't see them in ASCII, but you will see them in UTF-8 encoding for international character sets like Chinese. And I remember reading in this in the RFC, it actually mentions UTF-8 here. Oops. And says, what does it say specifically? Host component is allowed to contain percent encoded octets necessary for internationalized domain names, blah, blah, blah. And it mentions UTF-8 character encoding. And let's see, it's actually more strict at one point here. Right, a new URI scheme consists of characters from universal characters that the data should first be encoded as octets according to UTF-8. So we might actually need to implement our UTF-8 class earlier than I thought. Right, here again it says non-ASCII characters should first be encoded according to UTF-8. So it mentions it several times. So in our code, we're not checking for this, and this probably isn't valid UTF-8. We'll have to fix that later. For now, I just want to make sure that if we use either uppercase or lowercase or both, like that, it should all come to the same character. And actually, while we're at it, let's throw in some cases where we have multiple bytes. So 41, 41, 42, 43 should be A, B, C. And something like 41 for A, 43 for B lowercase is A, J, oh, that's A, B, C capital, isn't it? A, J, C, K. Okay, all right. So this should pass. It won't because we have not accounted for lowercase letters. Oh, I had a compiler error. Oh yeah, all right. It's back here. I forgot to. What did I forget to do? Finding the first reference in our code. Right, the path. The path is not a single string, it's a list of strings, but I was really only concerned with a single segment path, so first segment is what we want to compare with. And to be pedantic, I'll call that path first segment. All right, now we get the failures that I expected. So the first two passed, but index 2, or this one, fails because it doesn't like the lowercase a. So let's go fix that. That was in hex dig. It's actually not too difficult to change. We just need to allow lowercase a through lowercase f. And wherever we end up decoding it, I believe that's where we do percent character encoding. Right, our percent encoded character decoder. We need to make it a little bit smarter. So, right, here we go. Hex. We use hex there. So we'll need two different hex. So we'll say hex upper and hex lower. Hex lower. Lowercase a through f. And here's where we use x. We just need to make another copy to use the lowercase version of that. And I'm noting as I'm doing this that this repetition is code smell telling me that I'm going to want to combine these two into a common method. Did I forget to change higher to lower in a comment? Probably did. Oh yeah, you got me. Thank you. Give Rally Monkey a point. I don't have points or anything like that set up in my channel, but I have a feeling I'm going to be adding that at some point. Okay. Fix the comment. We have upper and lower case supported now. Hopefully our tests pass and we can move on. No. Okay, so. Aha. We have a different kind of bug than I expected. It looks like we accidentally ate the percentage, or I forgot a percent in our test case. What did I do? Oh, yeah, that's what I did. I forgot the percents. Percent in front of every byte. So bad test case. Fix our test case. It's passing. So, okay, we're down with, oh, back to my plan for tonight. Okay, we're down with hex digits. Can be lowercase now. Let's move on to normalizing scheme and registered names. So let's see if I already have a test for scheme. I think I do. Okay, I have legal and barely legal. I guess I don't really have one for different kinds of schemes. Let's add it nearby the legal and barely legal ones. Maybe we'll call one called mixed case or something. Mixed case. So, right, so let's try HTTP all lowercase. It's going to be just variations on this. So H capital TTP, and then maybe all caps. And how about one where it's capital and the rest lowercase. And how about one where the last is capitalized? And I'm thinking we can actually greatly simplify this. I don't need a struct anymore. If I'm okay with the actual string always being the same in the end, and we're just varying the case, then we don't need to actually encode that all the time. Our test vector replaced with just a string, greatly simplifying this section. And then we just say we always want lowercase http for the scheme. And we don't need, oops, don't need that. Test is complete, and we fail the test because it's not normalizing it yeah, that's exactly what we're expecting. And I noticed it's not printing the vector number. It's because I forgot to shift it out in that case. So let me just fix that. I kind of like to see a little bit of information about where. And I could be more verbose. I could print something else like failed for test vector element. Something like that. In fact, I could even put little markers in it so we see it easier. I mean, you can do this kind of thing. Sometimes I do it if I feel like it. There, it's a lot more clear here. Just because I'm a perfectionist, I'll put a space there. So now it's a lot more clear. You can do that if you like. It's an example of that. So let's fix our code. All right. So we're working on scheme, right? So let's find the place where scheme is parsed. Here it is. So we did a match to make sure that it checks out. So that's a great place. After we check out that it's a valid scheme, we can just do the normalization at this point. I'm thinking we're going to make a function called normalize case insensitive string. Oh, that's a weird capitalization. And it's always going to succeed, so I don't need to return a Boolean pass-fail thing. So I'm just going to make it a pure function. It has, not that I'm making it a pure function. I'm going to use the return value to store it back, so I can make the argument constant. So let's do that. Normalize case insensitive string. And thinking to be a little bit proactive, this sounds like something we're going to want to reuse elsewhere. We ought to put it in some kind of string library. I do have that one that we're going to be using more in the future, and probably end up putting it there. But for now, let's just put it in URI itself. So like before, what we do to add, oh, that's interesting. That should be the whole window, and I should see that. Okay, to add a new file, we go to VS Code because it's more convenient to create files in the correct directories. Let's take a file that we already have and just copy paste to duplicate it, and we'll call this, what was it, normalize case insensitive string. I won't have to type that again, so let me copy that name. Oh, that was foolish because I need to copy that, paste. Now let me copy the name, rename, paste. Make the files, and while we're here, we'll go and add it to our CMake. Source, normalized case insensitive string. That's for the header, and then the source file. Go back to Visual Studio, and it's not going to compile. I just want to run Visual Studio to rerun CMake so that our file will show up now. And there it is. And now I will start going through, rename things. This is really just a function. normalize case insensitive string. Well, again, this is our header guard, so that someone includes our header file more than once, it won't cause a problem. And here's where we're going to make the function. So this function takes a string and swaps all uppercase characters with their lowercase equivalents, returning the result. In string, this is the string to be normalized. The normalized string is returned. I should say all uppercase characters are replaced with their lowercase equivalents. So it's returning a string, and I need to make sure we include string. Don't need memory. It's going to take a constant string. That's it for a header. And now on to our implementation. Oh. The file we copied in character inset had a class in it. We need to mention that in the comment. Just realized. Let's do a quick detour to fix that. This contains the implementation of the isCharacterInset function and the characterSet class. And that's a function and that class. And let me check that specific change in, because that's a documentation cleanup. Is character inset fix documentation. Okay, detour done. This function, I need to copy the prototype. And then we don't need to include anything else. We're just simply going to implement it. I think we can make it very simple, because there should be a standard C library function that does this. I think it's 2 lower. Let me verify. Someone run my documentation program, and under C I'm going to look up 2 lower. Okay, so yeah, there is under C type.c. Curiously enough, it takes an int and returns an int. Although we know that in the default locale, it's just doing exactly what we want. So we're going to include that C type.h that the manual said. And let's make our out string. We're going to return it. Between those two, we're going to say for char C in string. And we're going to push the 2 lower onto the out string. I'm wondering if there's a C equivalent for the whole string. There might be, but don't remember. Might even be a C++ standard library function to do this, but it's okay. It's a little thing. Doesn't matter if we can reinvent the wheel a little bit. Okay, so I just need to make sure we include the header for that, and it should work. N comes before P. Trying to keep these alphabetically sorted. So let's build that, and let's see if that fixed our test right away. Thinking it might. All right, it did. So we got scheme normalized. Let's move on to the last thing I wanted to do, fixing reg name. And it's the same kind of thing. It's actually going to be a lot faster because we have the function now to do it. So let's go to our unit test. And I'm sure we have a section similar to this, but for the host. Here it is, host, illegal, barely legal, and here we go. So host, mixed case. Right, so in this case, the scheme is all the same, but we want a host to have some variations in here. It doesn't really matter what we do. We just randomly capitalize some of these. But in the end, we want the original host name here to come out. We call it get host. Right. So again, test-driven development. We make our test first, verify the test fails, and it fails in the way we expect because we don't have the code written to meet the requirement. Only after that do we go and implement the feature or make the change. So that host element, it's constructed in parsing the authority, right? And there's there's a whole state machine for building both the host and port number. A good place to do the normalization would be after that state machine's done. So here's a great place. I think it's just host, right? So host equals normalize case that says a string host. That should be all we need to do. Although I'm thinking this might not be exactly what we want because this will normalize it even for IPv future, and that might give significance for lower versus upper. Do I typically follow the test-driven development methodology? In the past, no, but I was converted into following it by a coworker, and the most convincing argument is that once you have a lot of tests built up over time, it really does give you confidence that your code is still working and you haven't broken anything when you make changes. But for me, it's actually relatively in a short amount of time that I've been using TDD. But now that I'm a believer in it, I try to follow it as much as I can. All right, so I was saying this normalizes it no matter what kind of host element, but really we only want to do it for reg names. We don't want IPv future might not be case insensitive. So one thing we can do, we don't need it after this method returns, but we can have a flag just to track whether or not it is host is registered name. We can assume it's not at first, and only when we know that it is, we can say yes, it is. And that's in this state, basically. And we, do we know right away? I suppose we do when we get to state 1. So now we can make sure we only do it if the host ended up going through the state machine in a path where it was a registered host name. It's also going to do it if the host name is an IPv4 address, but those don't have letters at all, so it doesn't matter if we normalize it. All right. Okay, looks like it broke some of the previous tests. I guess, yeah. I guess in some of our previous tests we assumed it came out unnormalized. Yeah, here's one example. So when it gets normalized, it's normalized to lowercase. Actually, here's a good place where we can sort of sneak in a test to make sure that IPv future address doesn't get normalized. We'll do that by just sneakily putting in another test vector where we make it a capital B, and that should come out without being normalized. Sneakily adding a test vector. I say it's always acceptable to add test vectors if it's giving you some benefit. Okay, we're still failing. Oh, look at that, the colon got eaten. Oh, no, it didn't. I just, I removed it from the input. It should be removed from the output as well. Okay, great, we're passing. Let's check that in. All right, so let's do this in 2 steps. So first, let's have a check-in where we just say we're adding the normalize case insensitive string function. And oh, I guess I forgot to check this in earlier as well. This was sort of a standalone change as well, where we're allowing hex digits to be lowercase. And that was a change in requirement, so we had a unit test for that, right? This is it, I think. And any of these other changes affected by hex digits? This was not. That's for the host, right? Okay, so to make that right, that changes in 2 places, in percent encoding and also here. And let's see if there was in any other place. No. So these are the places where we allow hexage to be allow hexage to include lowercase a through f. And the final thing we did, right, was to normalize scheme and reg name elements to lowercase. Right, those are all the changes that were needed for the tests, and these are the changes we needed in the code. Sounds good. So let's push that upstream. Okay, so I'm through with all the fixes I plan to do this session, so let's move on to some refactoring. I'm going to look at, let's see, from the smallest function up. Okay, one thing I wanted to do, this module is primarily about the character set class, so I kind of want to change the name of that. Okay, Rally Monkey says, silly stream nitpick. I'd like to have the chat overlay be semi-transparent. I can work on that. Oh, you missed down on a few characters? I'm sorry. I don't want to. I think it'll take me a little bit of time to figure out. I'll do that. I'll try to do that for the next stream. So I'll try. I'll work on that. Yeah. So this file started out being just for this function, but it expanded to be this class, taking up most of the concern for this module. So I really wanted to rename that. So actually, this is the first time we've renamed something. I'll show you what I do. We go to VS Code because it's easier to do there. F2 to rename, and we're going to call this character set. And character set for the header. It's very similar to adding new file. We're just going through and renaming instead of adding. And that's it for the CMake. I just thought of something else actually. Something I should probably do. So the CMake rebuilt our build system, so now the new name shows up in our Solution Explorer, but all our includes are wrong. So we'll just go through and fix them. Let the compiler's error messages guide us to do that. All right, and I think I probably forgot to change the header guard. Yeah, change the header guard character set. And the comment I just noticed needs to be fixed. So that little bit of refactoring done. Let's check that in. Oh, well, first, the rule is make sure our tests still pass, right? Now we can check in. No test should have been changed, but we have a bunch of Git changes. I just got the message from Git saying that there's a lot of garbage that needs to be cleaned up, so I told it it could do that. So you see something like this with the question mark means the file is missing, and then this means that the file is added. Git GUI doesn't understand that we did a rename. But if we stage all of that, and when we look at get status later, actually I think it's get k later. One of the two, it'll tell us that it recognizes it's a rename. So that's just these are all the includes. So this is rename is character in set module to character set. Push that. Really don't need to push upstream all the time. I just need to remember to do it at least once. Okay, so if we do get log -1, I think, stat, dash stat, you can see it recognizes it was a rename with some differences included. It's pretty smart though. It no longer says it was deleting a file and adding a different file. It knows it's a rename. So the other thing I wanted to refactor in this module was this free function. I think I want to make it a member method of the class. Only concern I have is that it might make it harder to read. So let's see how this is used. So it's like the result of the check is character in set character set. Would it look weird if I said check equals alpha is character in set C? I guess it's just the same. Maybe we can make it even simpler. Alpha is already a set, so maybe what can we use for a better name? Alpha includes? Or alpha has? I kind of like has, short and to the point. So let's do that. And it'll be like this, has C. Oops. Has. There's no has yet, so autocomplete wants to help me fix it. It'll be something like that. So let's go back to our character set and we'll just move this to be the method has. Oh, actually I already had it contains. Right. So we can just rename that to be has. And in the implementation here, alright, it was already calling contains. So it's as simple as doing that, and now we're done. And we'll have to go to all these other places where it got broken and change the syntax as C. I think that actually works out pretty nicely. Now, just because I think that this looks nicer doesn't mean it is nicer. So if I get feedback that it's looking weirder or harder to read, I'll change it again, certainly. For now, though, for me, it looks fine. Build that. Okay, so there are a couple other places, I guess. Oh, this was in the other module. Digit has a C. And then X lower. And yeah, maybe this is next on the slate to refactor, because this is pretty much equivalent. Yep. All right, so passed our test. Let's go ahead and check that in. So I did two things. First, I removed the is character in set. Remove is character in set function. Oh, and I just realized I didn't update the comments either. it doesn't declare that function anymore. It's all in the character set class of the character set class. And we'll put the namespace in there. We moved the isCharacterSet function and we add a renamed character set contains. I wonder if I should not rename contains and just say contains in the code. Actually, I think I will call it contains. It's easy enough to search and replace. There we go. And in the other, we'll repeat it here. And in the code itself, and in its header. So the net change now is I just removed this character in set. And everything is just calling contains directly. So that's all we really do. Oh, I skipped a step, didn't I? I didn't run the unit tests again. Still passing, good. All right. Yeah, so back in this percent encoded thing, let's get that fixed. So there's some common code here. What is it? It is that we are shifting in another digit. So let's just take that code out. And we'll make it an implementation method. We don't have any implementation methods yet, so we'll mark where our properties start and where our methods start, and we'll add it here. So this is shift in hex digit. And what does it need? It needs the character. This method, right, this method shifts. I need to not repeat the same word, shifts. This method takes the current decoded. No, it's not decoded yet. This method, struggling with words again. Maybe I'll just leave it shifts in the given hex digit as part of building the decoded character. It's sort of weak, but I'll leave it like that for now. This is the hex digit to shift into the decoded character. An indication of whether or not the given hex digit was valid is returned, because we can have an invalid character in there. So remove the impl because this is an implementation method already. And we want to, if we fall through, we return true. And now we'll just refer to that method everywhere here where we use it. If not impl shift in hex digit C, then return false. So we've simplified it a bit. Now the only difference in the state machine is that we were running it twice. So I have an idea for how to simplify that even more. Yeah, before I get carried away though, I'm going to check that in. Refactoring. extract shift in hex digit method from duplicated code in percent encoded character decoder. So my idea is that we always know we're going to decode exactly 2 hex digits, so why don't we just have a counter rather than having a decoder state. We would have a counter of digits left, and we'll start it at 2. And we'll say this is the number of digits that we still need to shift in to decode the character. And what we'll do is we will just always shift in. Just basically just always do this. And then just decrement digits left. Return true. And then done is if digits left is 0. Return digits left is 0. Now you might think, well, what if someone calls next encoded character again? Well, it's going to go negative. It's really going to blow up. Well, I have a rule for very low level components like this, and that's that they don't double check their, what do you call them? Preconditions and all that stuff. They tell you in school you want every function to always check their preconditions and stuff like that. But in the real world, it's best to do all your checking closest to the untrustworthy source. In my case, the untrustworthy source is the input to URI. By the time it gets down to here, I know URI code is already well tested in that it's only going to allow 2 characters to be shifted in, and then it's going to be calling done to detect, oh yeah, okay, we're done. I don't need to check here that it's not going to call this a 3rd time. Another argument would be if your low-level components are used a lot in a lot of different places. Actually, I'm kind of destroying my argument if I go that route. Let's do it anyway. Devil's advocate, right? I'm reusing this class in a lot of places, and maybe it would be too much duplicate code to have every caller make sure that they're doing the right thing and only calling this twice. Maybe I should do the checking here. I think what you got to do in the end is do a study in your mind, like what are the benefits of putting checking here versus checking elsewhere. Well, right now I'm using this only in URI. It's actually a private class inside URI, so nothing else is going to be using it. And we have URI well tested to make sure it's going to use this little class correctly. So in my mind, it's better to not check here because the checking would be redundant and slow us down anyway with no benefit. So anyway, our percent encoded character is actually pretty simple now. All the complexity has been moved out to the shifting into the hex digit, and we're really just making sure we only shift in twice. Let's make sure that this still works. It still works, so let's check it in. So refactoring. We don't really need a state machine, or I'll say formal state machine, for decoding percent encoded characters. We really just need to shift in 2 hex digits and we're done. Like that a lot better. Wonder if I can remove the other state machines to something as simple. You know, if I was thinking far enough ahead, I could have just written this from the start, but I guess it's my habit to start off with a state machine because I can kind of build it incrementally. And then when I'm done, I can look at the state machine as a whole and say, well, It's actually really simpler to just have a counter or something like that. And I will do it in the refactoring. In my mind, it's the same as if I had written this from the start. In the end, I end up with the same thing, but perhaps I gain a little bit more for the journey because I've tried out now both alternatives of having just a counter and having a state machine, and I've come to the realization the state machine was more complicated than needed to be. The counter was sufficient. So I feel good about that. I feel good about exploring both ways to implement it and picking the one that looks simpler and works just as well. Okay. Looking for things to refactor. I kind of like how simple character set is. This one is good. This one we just looked at. Back to our main body. We're actually doing pretty good. We haven't gone up in the size, and actually I think it was bigger than this before, so it's getting smaller. Looking for duplicate code. I don't really see any so far. This maybe. Some of these are very similar character sets. Unreserved and sub delimiters is sort of repeated. But then again, it is in the RFC. They repeat themselves there. So maybe it's good to be closer to the RFC. If someone looks at the RFC and then looks at our code, they can match them up one-to-one easier that way. Parse uint 16. I thought about making this more generic and a template. Let's wait until we do more parsing of strings to integers to do that. Fails match. Okay, this one, yeah. Okay, here's the state machine, and we're going to see a couple other state machines like this. I wonder if we can simplify this so that we don't need a state machine. It's really just two states. We're going to be doing this most of the time. I'm sorry, we're going to be doing this most of the time unless we encounter one of these percent signs, and then we're going to be doing that. The main thing that still requires us to use a state machine is that each loop is doing one character, and this percent encoded character is actually ending up consuming 3 characters. Actually, I have an idea. What if we already have this percent encoded character decoder, right? What if we ask it if it's done, every character, and if it's done, and we do this. If it's not done, then we'll do that. And we'll have to have this to initialize it in the first place. Yeah, let's try that. So at the percent encoded decoder, let's see if we can get away with it not having decoder state. Oh, and I just realized that's an unused variable. We don't need that either. So what we'll do is we'll just check first. If it's percent, no. We'll first ask if the PEC decoder is done. If it's done, then if the character's a percent, we need to actually reset it. Otherwise, we're going to check it to make sure it's legal, and then if so, push it. Otherwise, fail. Now, if it's not done, then we're going to be doing the shifting in here. And we have one more done check. Because once we shift one in, and if it is done, we want to take that decoder character out and push it in. I think this will work because when we first run into the percent, actually no, this will work as long as done is initialized to true, but it's not, is it? It's false. Well, actually we can fix that. I think we can get away with defaulting, where is it? We can default done to true and get away with that, right? Oh, done didn't have a state. Right, so That's not going to work. Let me think about this. We want I guess what we can do is we can have our own flag. Cool. And it's sort of ending up going backwards towards a state machine, but with a flag. I guess it's an okay compromise. So we'll say decoding PEC, and we'll initialize it to false. And we'll say if we're decoding a PEC, then we have this block. Otherwise, if it's a %, then we know we're going to be decoding a PEC. Start the decoder. And actually then we need to, oh, right, that's all we need to do, because then the next loop we will be decoding, we shift it in, right? So I think that's actually good. So we shouldn't need any of this other code. See if oh, I think I forgot to clear that, right? We want to clear it if it's done. Let's see if that worked. Okay, that worked. So let's do that same thing in the other state machines to try to reduce them. So this is the same thing. I wonder if it's similar enough that you can kind of combine these two. Let's apply the same logic first. So we didn't need these two. Instead, we have the flag. Right, so we say if decoding, then shift it in. Else if it's a %, do that, else that. So instead of that state, we say it's false. Instead of that, it's true. How am I? Oh, all right, here we go. First, to make sure I didn't screw it up. Now let me compare that with this. I think there's an option in VS Code that'll help us. I can go to that. Where was that? URI.cpp. Line 238. There is an option here to split the editor, right? So now let me give us some extra room here. Let me scroll this down. I should be able to line these up and see what's really different between the two. They're the same except for the character set is different. And the element we push to is different. So what if we were to make a generic method called decode element, and it would have 2 extra arguments. Actually, it doesn't need 2 extra arguments, just 1. We would just make this segment or query or fragment just called element, and we would have 1 extra argument, which is the allowed character set. That would let us combine these 2 functions together, right? I think so, so let's try that. Let's make it more generic. Decode element. That's a little bit too generic. I needed to say decode Can I just combine the names? Decode path, segment, query, or fragment? I'll change the comment later. What I'll do is I'll just make this more generic in its name, and then add the character set. allowed characters. Did I not? That's odd. Does it say it's undefined? Oh, because this is an anonymous function, and that class is in our URI namespace. That's why. So now here we just need to replace that. I don't want to lose that, so let's find where decode path segment was called. Instead we're saying path segment, query fragment, and then let me do something here. Bookmark, Control KK. So I can find where this was, grab that, and then do KK. Let's then go to next bookmark, KN. And then put it here, KN again, and replace it with allowed characters. I should be able to just ditch this whole, wait a minute, I can't ditch the whole thing. I need to find where this decode, so let me disable KK, KK, KN, KN. So now we'll replace this with decode path segment query fragment. And actually that we have to do that twice, don't we? It's down here as well. Something else came to mind. We could have kept that function and just have that be a single line function which calls that with that. That might be better. We'll do that in a moment. KN. And replace that with oh, we don't have to replace anything. We just drop this. But let me keep this around and just turn it into a one-liner for that. So this is just return that with query that KN with that. It's not working. Did I get rid of the other bookmark? I guess I did. Getting to be a long line, so let me split it up. Code path. So actually, I can remove my redundancy. It's still refactored because it's just a, what do you call that? Decorator? Not really decorator. Adapter. It's an adapter for this function. So that we don't have the caller to keep specifying that or specifying that more than once. That one should only be called twice from there and there, right? I could make another adapter called decode path segment, which calls that. But this is only ever called once, so I'm not going to bother. It's not worth it. In general, it's only really worth it to refactor in a couple cases. One is where you can remove duplication, and another is where you can make the code easier to read. I don't know if making another wrapper just to remove that text and then this is going to make it any easier to read, because you'll still have to find that line in the other function. Whereas when I had the decode query or fragment, it made it a little easier because I didn't have to repeat that part twice. Anyway, let's make sure that this still compiles and runs. Good, good. Okay, so there are a couple more percent encoded ones, right? Okay, so this one actually looks a lot like, doesn't this look a lot like the the function we've just been working on? Kind of does. So I wonder if we can reuse it, can't we? It's just with this as the allowed character set. So we are building user info. So we can say if not a decode, we're going to have to fix that name. User info. Okay, so let me fix that. And then the character set was this guy. Then return false. Can we get away with doing that? Let's check. Let's check and see. Our unit tests say we can. Well, let's clean this up. That name, I need to fix that. Really, there's all sorts of elements that follow the same rule where it's a sequence of characters, which can be the two things, a percent encoded character or a character from a restricted set. So what's a good name for that? Maybe we'll just go back to what I was originally going to call it and just say decode element. Let's do it as in a search replace. Decode element. Okay, and so now we can fix up the comments, I think. So this is element. This method checks and decodes the given URI element. We are calling a URI element. What we are calling an URI element is any part of the URI which is a sequence of characters that may include percent encoded, may be percent encoded, and if not percent encoded, are in a restricted set of characters. All right, so this is the element to check and decode. Decoded element, and then we have another parameter, which is the allowed characters. And this is the set of characters that do not need to be percent encoded. And then the return is that. I think that'll be good. Still passes our tests. Let's see if we're doing any more percent encoding elsewhere. Okay, we do. So is this the same? This is a little different, right? Because it can have a colon in it, and then if we see a colon, we're going to end up terminating early. So yeah, I don't think we can really fold that into that other function we just made. And really that was the only exception. So I think we're probably refactored percent encoding and percent PEC decoding as much as we can. It'll end up being called from two places, right? There and there. I think that's good enough. Okay, so what did we do? We did refactoring. Right, so we did a couple of things, right? We number one, we simplified the percent encoding to be a flag. This statement is not really a formal state machine anymore. It's just a loop where we use a flag to see if we need to run our characters through a decoder. Otherwise, we just check to see if it's either starting a decode sequence or if not, it's an allow character set. So first we replaced the more formal state machine used in URI elements that may have percent encoded characters with a simpler loop with a flag and a few conditional logic paths. And the second thing we did is we folded, or extracted the parsing of the above types of elements into a common method, which we called, I think it's called decode element. Right. So one place we actually did make it look a little bit more complicated, but that's the price we paid to make the function more useful. It's used in this other place as well. And I had that extra method, decode query or fragment. I left that because I didn't want to repeat that constant. Kept this guy, decode query or fragment around in order to prevent duplicating the name of the, not duplicating, but having to repeat the name of the allowed character set, which is common between query and fragment. However, the function is now just a very thin wrapper. All right, that's good enough. So yeah, sometimes I really like to be verbose in my check-in comments. I figure I'm doing myself a favor. Years from now, I'm going to be like, what was I doing? Why was I doing it? This is what I'll be doing. I'll be going back in time and saying, okay, I was doing work and then I was refactoring, doing work and refactoring. Well, what did I refactor? If the refactoring might not be obvious, then I like to have at least a good paragraph or a few sentences that gets my brain moving about, oh yeah, that's what I was doing, right? This one is maybe a little bit too verbose, but it can't hurt. It's something you read to help get your mind set in recollecting what you did and why. All right. We're good, right? Everything's up to date. So, should we do a bit more refactoring, or are we done with that for now? Parse path, okay. Parse authority. Oh yeah, I was thinking about two things here, right? This state machine is a little big. Maybe we can refactor that to be something simpler, or maybe break it up. And the other thing I was thinking of is this parse from string. It is still kind of long. We refactored it a bunch. One final refactoring step is, since it's really a sequence of things, and these things in the sequence has a comment, we could actually do like we've already done for this, have each step in the sequence just be a function call, moving this conditional logic into a function. Let's do that. So the first thing we did, actually let me check first. The tricky part will be is if we have any variables, like local variables that are carried from one block to another. I think one of those would be rest, right? That's fine because we'll just make this the function we extract here take rest as an argument. Same thing with path string. I think we'll have, yeah, so the worst case is we'll have a few input and output parameters that we use to chain together these steps. I think that's fine. We start with one of the easier ones, probably this one. So we'll just extract this method. This is parse fragment, right? Parse authority. After parse authority, right? It's probably a good spot. Parse authority is kind of, oh, it's big because of the state machine. Yeah, that's due for some refactoring, I think. This one's parse fragment. Don't know exactly what we need for parameters. We'll find out by pasting the code in there and seeing what we're missing. So we can get rid of these impls right away. See what we're left with. What we're left with is we need rest and we need query and or fragment. Okay. That rest part, that's always just the query, right? If anything is left is the query. It's the query, but it has this caveat that if it's not empty, we have to chop off the question mark in front of the query. So we'll leave it. We'll keep it calling it rest, and we'll say the rest is either empty or it's query with its little question mark in front that needs to be removed. So the arguments are query and or fragment, which can be const, and the rest, which is not const. This method takes the part of a URI string that has just a query and or fragment elements and breaks off and decodes the fragment part, returning the rest, which will be either empty or have the query with the query delimiter still attached. All right, so input parameter query and or fragment. This is the part of the URI that has just the query and fragments. Exactly. Output parameter rest. This is where to store the rest of the input string after removing any fragment and or any fragment and fragment delimiter. And our classic return value for failure mode, possible failure mode, is an indication of whether or not the method succeeded is returned. I think it's good enough because if methods failed, that means there's something bad in the URI, and that's all we need to do for this kind of low level component for now. So let's call that to complete our refactoring. If not parse fragment, query and or fragment and rest, return false. And that's an implementation method. Actually, does it need to be? Yeah, it does, because we have a side effect, which is restoring the fragment part in the implementation structure. Not all paths return value, right? I forgot my fall through. And actually, when I see that kind of thing, I can simplify it. I can simply say return that, which you kind of want to do because it's called a tail call. In some contexts, in some programming languages, a tail call like this can allow the compiler to do a bit of optimization. You can think of it as, instead of calling this function and then taking the return value and then returning that from our function, we can simply jump to that function and let it return for us. Makes more sense in some programming languages, makes less sense in others, but it's a good pattern to take advantage of if you see it. Once again, this is called a tail call. That's where the return is calling something and then returning it back out yourself. It works best when, of course, the return value of your function, the return value of the thing you're calling at the end are the same. All right, so still passing our tests. So that was one of the more easier ones. I guess this one's easy too. This is just going to be the decode the query. Parse query. Don't yet know the arguments because I'm being lazy, which is fine because we follow this general rule of remove impl. See what the compiler still doesn't like. It doesn't like rest, so that's all we really need. And it can be constant because we're not needing to modify it. Great. So some of this is going to be the same, so I'll take advantage of copy paste. This method takes the part of the string that has just the query element and breaks off just the query element with its delimiter and breaks off and decodes the query. And that's it. There's nothing left. This is actually the last part of the URI, so there'll be nothing left with the string. So let's, instead of calling it rest, let's call it query with delimiter. This is the part of the URI of the string that has just the query element with its delimiter. That's what it really is when we get to this point. And we don't need to output anything. Actually, it'll read a little bit easier too. If the query with delimiter is empty, there's no query. Else, the query is a query with delimiter substring to chop off the delimiter, which is at the front. And then we need to decode it. And again, we can make this into a tail call. Now we'll call it. And actually I can turn that into a tail call, can't I? Cool. Let's check that stuff in. So I think we're getting near the end of the stream for tonight because I'm in Pacific time, so for me it's 12:30 a.m. Wrapping up soon. I'll go over what we did, what we'll be doing next time, and then try to think of when I might stream next. I kind of want to get into having a schedule for whoever comes by to visit, just to be nice and let you know when to expect. I might be doing C++ again in case you want to see that. So I'll try to in the next half an hour try to come up with all that info. So let's see, what am I checking in? What do we refactor? We extracted methods, right? Extract methods to that parse the query and fragment. Okay, push that upstream. So just because we're wrapping up, let me go to the top of my solution and run my tool that checks all of our repositories. Make sure I see no M's or U's here. It means everything is checked in and then pushed upstream. Nothing's upstream I need to pull down. And our unit tests, make sure they still pass. There's no mistakes I forgot to catch. And what did we learn this time? I can fill these in later. Let me just go over what we did tonight. Once again, this was the 5th stream for this project. I started this really a month ago, but I really didn't get into it until the last few days. But over the last few days, what we really have done is we've developed this component called URI, which is letting us parse strings that may look familiar if you remember. We actually had where'd I put it? My notes. Where are my notes? Close this guy. Like in your address bar for your browser, and also used in other places. It's called a uniform resource identifier. So we've been writing a class that takes in a URI as a string and pulls it apart into its various elements, because we're going to need this class later in our web server we're going to write. It's going to be receiving strings like this, and it's going to need to pull apart, like, what is the host name? Is it the correct name? And the path. What are the parts, the segments of that path? And we need that in order to dispatch our request to whichever web service we have plugged in. Query and fragment, we need to have those ready in separate elements so that they're easy to look at for services that are going to use them. So this is sort of an important low-level component that we're going to use to help us out when we make the more important, bigger components like the web server and the web services that we write. And we're almost done. We have all the code in our class to do all that parsing. We can parse both good URIs and bad ones, meaning we have both positive test cases and negative ones. And we've done a bit of refactoring so that the code is cleaner than it started with, because I have the bad habit of writing unclean code at first. I need to do refactoring to clean it up. We've done that. We need to do more of that. And I kind of saved the best for last, so to speak, for this, to reverse the class and take elements and make the string is actually a lot nicer and easier. And we'll wrap up the class by doing that part probably in the next few days. And then we'll move on to a couple more low-level components I'm planning to do. And you'll find this, I have references for standards documents that relate to the project. We'll be able to check off URI. I think what we'll do next is internet message format, which is the format that's shared between HTTP for web server client and also email. That'll be a little bit like URI, but also a little bit different. And once we have these two components, and then this other one, which we're using to support international character sets, we'll be able to start work on the main objective, which is HTTP, Hypertext Transfer Protocol, which will let us build a web server. And then my pseudo-secret 6th objective is, once we have components to do web requests and responses, we'll be able to write a Twitch bot, because the way I understand it, Twitch's API is web-based, and when we have web components that can talk the web, we can make our own bot, which would be rather cool. That's the short, mid, and long-term objectives in a nutshell. And I need to, I'll after the stream ends, before I stream next, I'll be updating the to-do, and I'll think about this last stream, put in some retrospective, and write down any notes so I don't forget. And before the next stream, I'll have the plan for the next stream, which will be 6. And this notebook, there's a link below to get this notebook, to view it. Everyone's welcome to view it, and you'll get to see both what I did in the past, and also I have sections for links to the standards documents that are involved, and also any acronyms or terms that I use that you're not sure about, you can go through and see what I'm talking about. So I have a link to that below. So I think that's going to be it for tonight. Might stream tomorrow. I have a full-time job, so if I stream tomorrow, it'll be in the evening Pacific time, probably 8 p.m. we'll see how it goes. So I hope you enjoyed watching, and we will get this web server done. Probably not too much longer. In the grand scheme of things, a lot of projects take months, if not years. I think we'll actually have a web server going in the next month. So stay tuned, and have a good evening, good morning, wherever time zone you're in, and see you soon. Thank you.